Hi guys, welcome back. Today we are going to learn one of the most important concepts in Python and programming in general, object-oriented programming, or simply OOP. To understand why OOP exists, imagine you are building a game. In a game, you might have enemies, weapons, vehicles, and many other game objects. Every one of these objects has two important parts. First, they have data. For example, an enemy might have a name, a weapon, a health level, and they can also perform actions like move, attack, heal. Instead of creating separate variables and functions for every single enemy, OOP lets us combine both the data and the actions into one single structure called an object. Have you ever wondered how games create hundreds or even thousands of enemies without the developers writing separate code for every single one? One of the biggest reasons is something called a class. It's like a template that describes what an object should contain and what it can do. Suppose we want to create enemies. Instead of writing separate code for every enemy, we can create one enemy class. Then we can use that class to create multiple enemies. These are the objects. Even though they are different enemies, they all share the same basic structure. For example, they all have a name, weapon, and they all can attack or move. So remember, a class is the blueprint, and every enemy we create from that blueprint is an object. Okay, enough theory. Let's build our first class in Python. To create a class, we use the class keyword. Here we have created a class named enemy. Notice that it starts with a capital letter. This is a common Python naming convention for classes. Pascal case, where every word starts with a capital letter. It's not required by Python, but it's the standard convention you'll see in the almost every Python project. Right now, this class is empty. Python doesn't allow completely empty blocks of code. So we use the pass keyword as a temporary placeholder. We'll replace pass with real code in just a moment. And that's all it takes to define a class in Python. However, a class by itself is only a blueprint. To actually use it, we need to create an object. Here, enemy1 is an object created from the enemy class. And that's it. We just created our first object. Think of it like this. The enemy class is the template. And enemy1 is an actual enemy created from that template. The best part is that we are not limited to just one object. We can create as many as we want. So now we have three separate enemy objects, all created from the same class. But right now they are still pretty boring. Every enemy looks exactly the same. Let's fix that by adding data. For example, an enemy might have a name, weapon, and a health level. These pieces of information are called attributes. Attributes are basically variables that belong to an object. Let's give enemy1 a name. Now we can access this attribute, change it, or even use it whenever we need. However, manually adding attributes like this can become very annoying, especially when we create many objects. There's a much easier way to do this, but before that, we need to understand methods. Giving objects data is useful, but games aren't very exciting if enemies just stand there. So let's teach them how to attack. Sounds like a function, right? In Python, functions that belong to a class are called methods. Let's create our first method. Looks just like a normal function, right? Well, almost. If we try to run this, boom, an error. Why? Because almost every method inside a class automatically receives one extra parameter. That parameter is generally called self. Great, now our method works. But wait, we fixed the error by adding self. What exactly is Python doing behind the scenes? Self is a reference to the current object. It tells Python which object is used in the method. For example, if we write this, Python automatically passes enemy1 as the self parameter. If we call this, Python automatically passes enemy2 instead. You don't pass self manually, Python does it for you. This is what allows each object to access its own data. Now that we know what self does, let's use it to give each object its own data. For example, let's create a function named setData. And when we call enemy1.setData, Python automatically passes enemy1 as self. So these values are stored inside enemy1. Likewise, when you call enemy2.setData, Python passes enemy2 as self. So that object stores its own completely different data. That's why every object can have its own attributes, even though they all come from the same class. But there's one problem with what we done so far. Every time we create an enemy, we have to assign its attributes manually by calling this function. Fortunately, Python has a special method that helps us with this. In OOP, we call this the constructor. Now, whenever we create an object, Python automatically calls the init method. The values we pass in are assigned to the current object's attributes. So behind the scenes, it's like writing this. Anyway, now every object can have different data while following the same class structure. That's one of the biggest advantages of object-oriented programming. Okay, now let's combine everything we learned into one complete example. Like this. So we created a single class, but we use it to create multiple different objects. Each object has its own data, but they all share the same behavior. That's the core idea behind object-oriented programming. Today you learned how to create a class, objects, attributes, methods, and constructors, the building blocks of object-oriented programming. This is just the beginning of the series. In the next video, let's talk about inheritance, one of the most powerful features of object-oriented programming. See you in the next one.